we stop at the page 36. Okay, the rule of thumb in the previous session we talking about the rule of thumbs will provide us some numbers, and these numbers could help us in two aspects. One is to plan forward the classroom planning. At the very beginning, we can have some idea to start with how the classroom will be arranged inside the building and get incorporated into the building layout. Give us some this kind of idea for the engineer. The second point to help is to cross-check our detailed cooling load, our loading calculations and detailed design. Check against those of the design as compared to the typical buildings, typical cases. See if our case are also the typical, so that our calculation should be fall within the reasonable range, typical range. If our case is very special, okay, for an engineer, he or she can judge, okay, this special condition should be more demanding or less than the typical values, so that we can check against, compare with the typical values, see our calculation, is this in the reasonable range or not? Okay, so the rule of thumb could help us in that way. In this page, I show some more examples which the rule of thumb is the system dependent. Say, for example, the number of lifts. We do not have the number of lifts in our previous design guideline. Say a general rule of thumb for the office building in Hong Kong, if we do have per floor arrival rate is around 15%, a general rule of thumb is that one office leaves, rule of thumb for the office building of floor area 1,000 meters square per floor within the zones, or say 10 floors or 7 floors, approximately require one lift, approximately. For this case, not one lift, so sorry. For this case, 1,000 meters square, in general, FH, the poor surfaces, 5 floors are lifts. This is I think is an absolute minimum acceptable. So that in the day, okay, you go to the site visits for the buildings, take a look about the lifts, how many floors there, how many lifts in number, okay. Say, for example, in the Jordan, okay, just near our campus, there's a lot of commercial building. They have the clinics, the shops there, office floor shops, and usually they have the 3 floor one lift, okay, around 3 to 5 one lift. For some high class building, okay, 2 floors are lift in total. Just count the number, you can get approximate idea, okay, about this arrangement. This is only an average value, so do not give you the exact solution, but to give you, okay, is it just a line between some reasonable range, okay, in there. This is interesting. Just to give you one more discount example. Okay, second part of the lecture, classroom content. Okay, we try to emphasize on the PSA examples. Okay, hopefully it will be helpful, particularly onto your design exercise. Future. Okay. We are not going to the guidelines levels. We start with the philosophy levels, which means those are the guidelines are set out based on the basic requirements. These basic requirements will be universal. Universal means that apply to all scenarios, all regions. But for the local standards and local design practices, may have their tiny modifications, fine adjustment about the details and details numbers. However, the considerations more or less will be on the same directions and the same basis. Therefore, I think for the degree student training, we're better to start with the philosophy, the basic consideration there. Once in the later stage, in future, you get appreciated with some design guidelines tables, you can recall those of the principles to get realized, the number is designed in that basis. Okay, these are my intention to include this part. Okay, philosophy of the classroom design. Basically, for the classroom, we need to consider 3 things. Okay, the basic consideration, which is the risk of the task of staff. Okay, and the risk of the task of the staff. Therefore, basically, we can subdivide into 3 different consideration directions. One is what kind of task is to be conducted. Okay, for the planning design, what types of tasks will be conducted there? For this task, of course, is a type. Okay, the second thing is important, how difficult it is, which related to the duration of the staff staying there. How much work will be related there? How much tool is required there? Okay, how many processes are we undergoing there? Okay, how frequent this kind of task will occur? Every day, every hour, or just once per year, such as inspection, yearly inspection, or maybe once a quarter, okay, once a month, or just once a building lifetime. Just for example, replacement of some equipment, maybe once every 15 years or even 20 years. Okay, this frequency also important get related to the paradigm design, the provisions. Okay, for those of the types, difficulty, and frequency, we will evaluate about the risk of the task. Okay, the risk of the task. Okay, there's another word, hazard, quite similar, quite confusing between the risk and the task. Hazards. Hazards, we're talking about the particular hazard, say for the falling. This is a particular hazard. The staff fall onto the floor. This is a hazard. The risk, we're talking how likely this falling will be. Okay, therefore the risk put forward the risk into the frequency. If the plans just inspect once a year, okay, is less likely. However, this is the difficulty because the task is conducted at a very high level. The risk is really higher because falling is have the heavy injury. Okay, things like that. Okay. This is the task related for the program first factor. The second factor is we consider the hazard. The hazard is we are going to identification of the particular hazard types. Get injury, falling, hot work, or some others, cutting your fingers, and this is identification. And then with the hazard, we can evaluate about the risk. Could be at the quantitative manners, also could be on the qualitative manners. For the planning design, most likely will be the qualitatives. Okay, just a judgment, category, descriptives. Okay, no need to do a very detailed risk calculation, probability, no need. Okay, usually not. The type of people, the staff. Okay, could be a technician. Okay, actually conduct the work. Could be the engineer, inspector for supervision, and how many staff will be there? A single staff, a pair, or a team over there. Very depending on the job related to the task and related to the process. So that these three factors, I try to describe the planning design and subdivide it try to organize in this manner. Okay, so one by one. Okay, the first group is a task type. Okay, the categories for the task could be further subdivided into the operation. Okay, the system operation, the monitoring purposes, or the inspection purposes, or servicing and maintenance. Okay, operation actually get the system work. Okay, monitoring to check against its status, inspection to certify the parts according to some standard, servicing, maintenance for the repair during the lifetime. Okay, task type. Okay, for operation and monitoring usually require no more than observation and operation of simple operation controls. Okay, this is operation and monitoring, adjusting the valves. Okay, take a look on the meter. Okay, switch it on and off. This kind of operation, get access to that. Okay, the last three involve insert work or without dismantling or demounting, removal, or off-site overhaul. Okay, and okay, required no monitoring, inspection, surface maintenance. Okay, not the big. We are not talking about very extensive work over there. Demounting requires a more local space. Okay, and the local overall requires surface base and also longer duration. Now, these are task type get related. Okay, the task difficulties. Okay, difficulty is a function of type in the location, activities, and the physical action required. So we need to know, okay, what's exactly the task to be conducted in the classroom at a particular location. Okay, so that we design the classroom to suit for that. Okay, and ground position may often be a cause of the accidents, which are difficult position, climbed in height. Okay, so that the guidance on the space need to lifting and lowering are considered. Okay, for those which are related to the staff ergonomic. So here are some examples. This will come from the British standard, probably for worldwide people more or less on the dimensions approximately there. Okay, and this is an illustration. That's how the work is to be conducted related to the ergonomic. Say the people are laying down to do something work. We need the dimension requirements. Okay, for the pathway requirements, the minimum is around this figure, absolute minimum 550. So that just for example, for the architecture recommendation for the corridor access inside the room is 600 in some standard. Okay, at least this one I used it in when I was the training engineer. Okay, so we have the idea that already 500 or 550 are the absolute minimums to the pathway. Therefore, allow 600. There's a reason why. Okay, preferably 750. Okay, 2.1 meter. That's the reason why once we say, for example, for the local practice talking about the fire surface access. Okay, there's a minimum clear height 2.1 meter from the floor finishing level up to the lower part of the sprinkler heads have to be maintained for fire escape route for those who access. Now we can get related. Okay, this related to ergonomic. All right. Therefore, the principle is there. So we do have the information, the ergonomic information with the dimension there. So that once we design the problem, put the equipment over some locations, we need to know what kind of work will be there and to allow some surface space over there. Okay, based on the reference of the ergonomic numbers. All right, so that we have some rules in there. Third example, say 2.1 meter. Why is that? All right, this is related ergonomics, and how deep of the stairs. We have the optimum range. We have the minimum. We have the maximum. Okay, not more than that. So in here, from this example British standard, we do have some idea when planning the classroom, access and also the surface space required. Actually, those of the dimensions also get related to the basic ergonomics data, and this ergonomics data are including the dimension, also the physical strength. Say a staff is required to conduct some maintenance work, to lift something or detach something using the hand tool. The strength expected for a normal staff can be assigned in there. Okay, at the different location, there's expected strength of the weight. Okay, for the operations. Okay, more than that means he or she need an additional tool. Okay, to help, or more people is required. So that according to those of the work type in the process and the task, we can arrange the space required. Okay, therefore at the very beginning, okay, we don't know. I was a student, I don't know. Need to ask more. Okay, from your senior engineers. Okay, if do not, we can search through some examples. Okay, some example classroom, such as some I show you at the beginning. We can discuss. Okay, why the space provided there, how it will be used, and try to get relate to this basic philosophy. All right, and then you can understand more for planning the future of different classrooms. All right, task frequency and duration. The principle is that easier access for more frequently performed tasks. Okay, if the task requires more time, lengthy tasks, okay, it also justified for the easier access. Okay, these are based on the imbalance of the economic as well as the safety concern. All right, and what's the point to be determined? That's negotiable, but the principle is there. Okay, more frequent, more lengthy tasks. Okay, use the easier access relatively, so that at least you have the qualitative comparison for two classroom access. Which one should be more easy? Which one should be less easy? Okay, you have some mind to compare it, to place the classroom location, or you may find that some classroom location requires some more easy access. You can negotiate to trade off, okay, with the architects. Okay, that's the principle is there. Okay, the hazards must be identified and clearly, okay, and estimated made based on the risk involved. This estimation not necessarily the quantitative, but qualitative is sufficient. Here I provide you some examples: falling from heights, tripping, explosion. Explosive sometimes is a concern, say the dust environment, dust explosion. Okay, in the some electrical ductwork, switchboard. Okay, there's a subject to exposure risk. Petroleum vapors, methane. Some lubricants may be vaporized and then get a flammable vapor is concerned also. There are various approaches to the evaluation risk, ranging from very complex fault tree analysis, not necessarily usually for the classroom, but for the single events, just a reliability, a checklist. Okay, some checklists to take to count the number of checklists, all pass will be okay. This kind of thing, we have a lot of these kind of tools, and I think in the higher level elective subjects will provide you more techniques on the quantitative risk analysis. Okay, could lead to deaths of many people, to a less complex qualitative approaches where the hazards may only lead to the minor injury. Usually we focus on that for the classroom, unless for the more serious cases. But usually this in general will be good enough. The staff types, supervision and team size, okay, must allow for the in-house staff not familiar with equipment and external specialists not familiar with the plant's space. Therefore, once we designing the plants, we need to allow the less familiar staff get access to the classroom. Sometimes the senior want to take an inspection over there. Okay, this occasionally occurred. The access must make allowance for the number of staff need to undertake the particular task. Okay, some tasks require more than one people. Okay, so we need to get good understanding about the operation, so that to assign sufficient spaces for working. All right. For the basic hazards, I have a list over there. Allowance normally made for the hazards below in terms of the basic access and the provision of extra spaces where the hazards cannot be treated or avoided. Okay, if avoided, that's okay. If not, we need to additional spaces. Okay, for safety concern. Say the hazards that typically are the hot surfaces, cold surfaces without insulation. Okay, the pipework, no insulation, is very hot. Okay, boiler room, sharp edges, ends get injury. Okay, skin usually occurring on equipment support. Okay, so we need space for protection. Okay, hazardous atmosphere, explosive dust, we have mentioned, vapors, petroleum vapors, and methane, etc. And projecting parts of equipment, the moving parts. Okay, some moving parts, pumps, rotating. Okay, particularly at the head level, angle level, allow for the most extreme protection components and items. Okay, this right. The basic hazards, also the typical one I listed here: unprotected moving parts. Therefore, if this is unavoidable, to mark on the floor, logo area. Okay, dangerous area to access space, things like that. Get those areas away from the general access. The need to work on live electrical parts. Okay, mark on additional space for that. Flammable materials, handling space, and this space are related to the operation, trying to subdivide it, the flammable liquid. I think there's one example recently I found that in some non-industrial premises. I think recently some people try to produce some hand washing gel using alcohol. They use a very big pound of alcohol, put inside the shopping mall, open space, try to mix it. Okay, there's a two concern. One is the storage. Okay, the storage cannot be that huge on the fire. The storage risk. Another more important is a processing risk for fire. Okay, the processing, because you try to mix something not in the industrial provisions. Okay, therefore in there, flammable material handling space or liquid, actually the allowance has been assigned to the industrial area for processing the production. Okay, but not in the general residential building, not in the general institutional building. That's a hazardous. That's a dangerous. Okay, I think this is a recent good example. I observed it from the environment. Okay, toxic materials, flammability materials also. Noise. Okay, probably the hazards. Noise is not hazards. Okay, such as we did mention in the last week, we're talking about the noise exposure for the workers. We need to protect. Protection is required. Okay, the basic hazards are listed further. Is a heavy work, okay, sharp objects, okay, which require lifting eyes, runaways, and some more techniques require special tools and protection, glove, okay, which require additional space. Okay. Full hydroplant space below the eye, when the way remains free other surfaces, probably is required for such a particular work type. Okay. Falling from heights, okay, from the walkways, from the protected ladders, connected with the access routes, okay, have to be obstructed. The obstruction, this additional barrier, requires particular space, so that the assignment of the plant room, okay, have to consider those of the hazards there. Tripping, provision step cover, things like that. Okay. Further, the basic hazards below normally deal with by warning signs. Give us some example. Usually by the warning sign, but not the others. Okay, which must not be obstructed by adjacent surfaces, so that the space is required for the signage, as well as the vision. Okay, the visual provisions. Okay. Insecure hand and foot holds required. Do not walk, do not land on, do not use the support sign is required. Do not cover it by other surfaces, other equipment. Consider designing all hangers or equipment load plus the weight of the two operatives. Escape routes have to a good signage over there, should not be covered. Therefore, not covered means the space required. Chemical storage, handling, water treatment, signage is required. Alright, the general principle to notes for the maintenance and other space required. The general notes principles. Routes to the plant equipment should be as direct as possible. Simple is beautiful. Okay. First, the second is a standing room should be provided at the end of the groundway and the near the equipment. Okay, the standing rooms near the equipment is the best. Okay, because there you need to work something, stay for longer. All right. Access ladder platforms are required for high plants. Usually the height higher than 2 meters. Okay, less than 2 meters. Say for the local now, I think the requirements, all the you cannot purchase from the market a very tall ladder. You don't. Okay, usually less than 2 meters, because more than 2 meters in general compromise that we need to provide a fixed access ladders and platforms. Therefore, those of the movable ladders will not produce higher than 2 meters. That's the reason why not available from markets. Okay. Apart from those are non-standard, not comparing to a certain safety standard. Permanent or frequency access, temporary or infrequent access. Okay, this. Assets for maintenance, mobile assets, gear should be capable of lifting equipment as well, depending on what kind of that. So I think nowadays you are very difficult to find a ladder without working platform, because expectedly we need to do something there, but not just for inspection. Therefore, the lifting equipment provisions nowadays is required in the market. I think the requirements is changing, but the principle is still there. Personnel and may be allowed to temporarily compromise assets, but not escape routes. Usually, okay, very much is a principle. And as a general rule, escape routes should never be compromised if unavoidable risk analysis needs to be completed. Which means in all cases you need to maintain the access routes. If just some unavoidable cases, okay, you may block the access, let's say, for 5 seconds. Okay? We need to conduct a risk analysis, see whether we can keep the same risk level by providing some other additional provisions due to the reduction, due to the defeated escape route scenario. Alright, these are so-called risk analysis. Doesn't mean you just calculate something and then pass. Doesn't mean that. Which means we calculate something based on we provide additional protection so that the risk level will not be worsened. Okay, we keep the same risk level. That's the idea. Cruncher runaway should be decided to allow a transfer to the trunks, the trolley, rollers, those of the tools, and okay, and point to the lift to minimize space compromised. Okay, step overs should be designed to carry the weights, the objects likely to carry over them, particularly for the high one. You need to provide some steps. No? Local lifting gear may be required for such circumstances. Right? So in this the maintenance task, there are some illustration example of the relationship with the frequency of maintenance and the level of assets required. Just give some example to let us to understand what's the difference there. Say the maintenance task very frequent, okay? Therefore, which means clear and immediate access is required. And then we do have some example, okay, of this kind of applications. So that for the typical access, if not for high level, maybe something like this. Okay. In the figures doesn't mean we must provide the provision of this. Okay. But to give us some idea, the different levels of access, try to relate to the frequency of the maintenance work required. See, for occasional frequency, okay, which means a semi-clear access is required, such as discount activities and the example. Okay, and for the infrequent maintenance, repair, replacement, just once few years, okay, close access could be considered, and now some secure later, okay, and of course, showing here just illustrate the principles, okay, for those for the frequency. For the access of maintenance, the access egress route must be sufficient in terms of the space provision. You have the dimension of ergonomic requirements. And loading the capacity, you need to know about the process. To allow the safe movement for the maintenance staff, the handling of major plant items, and also use the mechanical lifting devices where necessary. Okay? If the consideration of access to the plant above 2 meters falls from the height is a major concern. Okay, more than that. Right? There are 2 aspects to consider. Maintenance work access the working position. We could consider for such a case more than 2 meters. Portable ladder. Okay. Less preferred. Okay. Scaffolding. Okay. Power working platform. Okay. Or working space around the plant. We can build some walkway depending on the working frequency and type of work. Okay, the working platform around the plants may be permanently or for frequent access. Okay, or temporarily for less frequent maintenance. We do consider. Okay, so that this still allows some space for that. The workplace regulations for the different country we may check against those of the workplace requirements. All right. Assets of maintenance and employer got obligation to provide safe access and egress in all time. There's the law. The distinction needs to be made between the access route to a plant item and the space provision around the plant necessary for safely carrying out the maintenance task. Okay, so that the space actually requires two different categories: one for the access, one for the safe working environment. Okay, the provisions of access must be appropriate to the frequency at which a certain task will be carried out. Tasks which need to be carried out on a daily basis, or say for example checking the equipment for the safety reasons. Boiler is a high risk equipment because it's subject to exposure risk if overpressure. Therefore, have to be checked regularly, closely monitored. We need to open an immediate access. Okay, these are for the boiler. Some pipe works. Okay, here are some examples. I don't read it out one by one now. And of the frequency of the maintenance will influence the level of access. A reference definition here, just for you, for example, what is a frequent, what's occasional, what's infrequent. Just for example, say less than monthly. This may refer to the frequent. So for the weekly check, daily check, monthly check probably is borderline between the frequency and occasional. Okay, half a year, quarterly, occasional. More than that, infrequent. So this give us some idea. Sometimes not perfect on the site condition, but at least we have some information. Okay, all plant valves control terminal units. Terminal units, say the air supply, the fan coil units, VAV box. There's terminal units, which require frequent maintenance. Okay, and operation should have a permanent, clear, and immediate access with adequate space provision to carry out a practical, particular task. Okay, if it is enclosed, a hanged door should be provided. Okay, a hinged door will be provided, which opens outwards to fully open. I do have an example figures. Okay, show you at the later stage. Access or maintenance on an occasional frequency for maintenance tasks which for occasional frequency can be readily achieved by removal clearly marked hatched floor traps. Okay, some cover. Okay. Occasionally access, just lose the screw and detach it and then get access. Can be the accessing panels, tiles, in the floor ceiling, or the wall partitions. Okay, which can be operated by quicker release fastener, preferred for the screw driving fixing. So these are for occasional frequency suggested access methods. All right, which difference? For the infrequent maintenance, right? The infrequent maintenance or emergency repair, replacement of ductwork, pipework, terminal units should be considered in that way. Here are some examples. The removal of demountable partitions, doors to gain access may be appropriate because this is infrequent, because it's emergency repair. All right, this is considered suitable. The removal of mortuary walls sometimes not considered too reasonable for the maintenance. Okay, unless for very infrequent maintenance. Just give an example. Say for the Causeway Bay, we do have the Times Square. Times Square, the main plant room at the 12th and 14th floor, the main chiller plant room, even the transformer. All right, the replacement life cycle, talking about deckham equipment, around 20 years, 15 to 20. Therefore, the maintenance work have to demolish the building facade. There's allowed some openable facade. Okay, demolish it. Okay, and then hang the equipment from the ground floor. Okay, apply the road license. Okay, get it completed overnight. Okay, get it replaced. This for this kind of the maintenance or replacement is justified because of Causeway Bay. Okay, Causeway Bay is a very high rental price area, so that the lower parks are used to earn monies. Right? For the higher parks, we justified it for the economical reasons to put the plant room at the higher levels. That's the reason why. So that the judgment are based on the principle there. Right? The issue of whether permanent clear access is necessary in emergency repair needs to be agreed with client. Okay, not only the client, to all the stakeholders in your design team, got a collectively weigh out the solution. Provisions should be allowed for removal and replacement of pipework links in a surface duct, usually. Okay. Okay, the duration of task consideration. Duration cannot be defined so easily because this is related to the operative fatigue of people. This is depending not only on the complexity, physical requirements, but also the access provided to the environmental conditions. Hot condition, dark condition, a lot of the environmental constraint, very humid condition, things like that. In general, access should be considered for any task other than observation, which occurs in above head level, okay, below hip level, okay, and those of the work last for more than 1 minute, which need with more space. All right, so that we have some reference for the duration. Alternative handling procedures should be sought if some other requirements, laws, some others specified in before. Okay, the location laid out of the plant rooms. The properties of plant equipment and characteristics of normal building construction limits, okay, the practical location of plant room, and these are quite related to the building technology. Okay, I think you should have some subject on the building technology and the building overall planning. Okay, and this properties of plant also affects the building construction. I list several items over there, say the weight, okay, and the weight which related to the structural consideration, okay. The consider not only the weight of the plant itself, also initial installation, also for the surface or replacement during the working process. We need to allow them, right? Such a chair, we need to consider during the replacement process. Okay? Physical size, the area, headroom. Okay, I think the rule of thumb is okay, provide you some reasonable range and then some idea for the additional spaces required for the surfacing and removal. Okay, we do have some example going to present to you at the last section. Design of a floor slab other than the ground floor, not usually designed for support heavy weight. Okay? Particular item require the lifting gear attached to the underside. Right? If a slab is required to bear the full load, lifting device provision should be made in the structural design, such as a hanger. Okay, some hanger pre-built in the plant room. Okay, for lifting the equipment. All right. Also, two more items in this page. Okay, location and the layouts of the plant rooms, including the ingress and egress, loading facilities for en routes to the plant room are necessary, and where the size and weight carrying capacity, either the limited, smaller, or easier dismantled plants must be used in such a case. If those of egress are insufficient, therefore we need to locally assembly equipment. Give you an example about there's a main switch cubicle, main switch room. There's a switchboard, very huge one. Okay, for the factory built equipment, the cubicle is much better in the insulation workmanship. Okay, however, for some plant room, the access for the main switch room is insufficient to allow the access. Okay, therefore those of the cubicle have to be assembly on site, right? There's a particular requirements for egress, ingress requirements. We have this kind of possibilities, pros and cons, right? Better in quality, but require more space. Cannot provide such provisions. Probably we have to use the site assembly, going through tests, but less preferred. All right, we need to trade off for the plant room. Therefore, why I emphasize that we need to acquire more experience on the practical side in order to design for the plant rooms better. Escape routes, the options for the escape routes in the basement will be very limited. So that for the basement plant room, we need to think in more careful manner. Okay, for the access, the ease, the frequency, these kind of things. Try to as a norm, okay, try to provide the same surface level at the upper ground floor. If I have to be degraded for the provisions, you need to get agreement collectively for your whole design team. All right, particularly the client who is going to operate and upkeep those of the surfaces. Maybe I can give you one example for the basement. Basement plant room, the gateway. Do you know the gateway at the Tsim Sha Tsui, next to the Ocean Center? Ocean Center, and then the gateways very close to the ferry go to Macau. Okay, there are two tall buildings. In the gateway, the power station transformer is the basement. Okay, basement 3. Okay, and no access road go to there. Quite special design. It's compromised with CLP, China Light and Power Company, Hong Kong. Okay, and the access is go through the 4 slab. So for the basement, there's allow a 4 space without any permanent shops over there. If require the maintenance to replace the transformer, demolish the part of the floors. A block, there's a hole, okay, from the ground floor down to the basement 3. All right. Therefore, this example I like to illustrate the basements is quite difficult to get access, so that we need to have some more efforts to design the escape routes as well as the maintenance space. All right. But for those the case I quoted, these are subject to the compromise between the surfaces and as well as economical justification as well. They need to calculate a lot. Okay, they need to pay more for the each time maintenance, but they can have some return of money. Have a very complicated calculations. But anyway, there's one of the possibilities. All right, location layout of the plant room, the building related factors when inadequate may affect the possible plant room location. Say, as I mentioned in the previous example, increasing the floor or the wall areas may be required beyond the values that would be expected, that we found from the rule of thumbs, which I mentioned that this is so-called a special case other than the typical case. All right, so that we can have some idea in there. There's a special case to make the additional judgment on the additional space required and the plant room provisions. Okay, this special requirements such as relationship to outgoing surface. So we need to know how the system is arranged. What's the relationship? Say for relationship, give an example. Say the chiller plants, main centralized chiller plants, big chiller, require electricity. Okay, how we arrange the electrical cables supply this heavy loading. Some equipments, this kind of chillers may require high HV supply, high voltage supply, or some loadings, okay, probably needs to require more than one transformer to supply the entire plant. So that the special arrangement, the relationship with the transformer room and the chiller plant and the supply ductwork and the main switch room, they are related. So that we need to understand the relationship in order to arrange the plant room together, right? So I listed down here is a must be linked dedicated electrical ductwork, pipework works of adequate capacity. Also, the links have the significant length other than building space and may be compromised because it's the major road. Right? Okay, another have to consider is the height of the plant room. Inadequate heights of the plant room will increase the plant room area because the equipment have to put in the upside down, okay, something like that. The plant room area at the point of the exit surface will be congested, okay, so they need more space for the access as well, which will limit the number of surfaces that can exit to an adjacent riser without compromising the access. So that we need the additional room area. All right, so that is a particular case consideration special. And a clear plant space columns may obstruct the withdrawal space and access, so that the beams columns which will affect your plant room size. Some, in terms of area, may be sufficient. However, if you've got some beams inside, you need to assign a clear space, including the access, etc., for your plant room. Okay, for the layout. More point, the general rules are apply to considering access. Space requirements for the O&M activities may not be adequate for functional requirements, such as functional requirements. We need to allow some distance or more from other plants, from cooler chiller, which may cause the recirculation of the cool air, okay, due to the functional requirements of the equipment. And space required for future plants must be compromised. Okay, must not be compromised. Okay, if there's a plan ahead for future plants, so that the provisions we marked. Okay, mark the wall, mark the rooms, put something there. The space eventual purpose should be reserved. Okay, we usually do it in that way. And other items of equipment or the building fabrics must not be affected by the O&M activities on a particular item of plants during the working. Okay, if the equipment is noisy, the maintenance otherwise dangerous, consider locating duty and standby equipment in separate space. Okay, so that they will not be operated at the same time. Okay, in terms of the noise. Equipment should be laid out in a way that creates a shared access space between items which not maintained simultaneously. I think I gave an example in the later sketch. Some maintenance space could be shared if two equipment will not be maintained at the same time. Okay, this one of the considerations. Escape routes must not be blocked by the O&M activities, operation maintenance activities. The rule can be relaxed, okay, if there's an alternative escape route. Otherwise, we need to do some risk assessment. Okay, try to see what kind of additional provisions should be provided in order to maintain the same level of risk. Here's an example. Allow for the access of hinged components such as floor panel doors, boiler burners, access panels on the underside of plans of ducts, okay, etc., etc. Okay, allow for the fluorescent projection for the components and item equipment, okay, to avoid tripping hazards, to a low-level access space, running pipe, etc., etc. Right? Okay. Let's give me 5 more minutes, and then we have a break. Motor control panels should be close to the plant room normal entry door, because the motor running. Okay, once the access, we need to check the motor's status, and then switch on and switch off the motor, etc. Usually close to the plant, next to the plant room entrance door. Large plant room should be close to the main access door, because large plant room means the accessible frequency. Or specialized removable wall and the wall panels. If the plant is even too large, okay, we may think about the removable partition within the building, so that we need to make this allowance for closely coordination of the architect. Consider what items of plants can be located in the same space, okay, and what items must be separated in order to plan for your plant room. Say here are some example: air compressor, boiler from the chiller. Okay, must be separated. Okay, because the boiler is heating. Okay, chiller produce cooling. It's not energy efficient. Okay. Also, we have some consideration. The boiler requires the petroleum supply. The accessory will be complicated or dangerous, subject to safety concern. Say a larger or emergency electrical generator must be separated also, right, from these major plants, and their associated equipment have to be together. Okay, keeping away is not a good practice. Say just for example, let's refer, but we have the usual case. Say the roof emergency generator. Okay, but the ground floor changeover switch is sometimes necessary. Although the electrical generator get related to the changeover switch. However, the generator also have the exhaust chimney, okay, which is subject to the environmental protection concern. Also the noise generation. Okay, so that the generator unlikely to put at a very low level, which affects the occupied area with the noise of the testing and the inspection also. Right? This limits area affected is control and is a rescue operation for the plant's relationship. Okay, the last page before the break. The location and layout of plant room. We need to allow the adequate space for items such as breathing apparatus. Okay, people access there may have some apparatus. We need to allow additional space. So that we need to know what exact processes to be conducted for the maintenance. Eye washer, okay, showers, okay, close to the point of access, and we have to allow space for the emergency lock-off control, close the normal access door, etc., etc. Okay, let's have a break for 10 minutes, and we will resume at a quarter to 5. All right? Okay, just enjoy. Sorry for long lecture today.